provide you with a little history, the initial concepts for the Unified Modelling Language were developed by Grady Booch, Iva Jacobson, and James Rumbaugh. They were early developers of automation methodology, primarily rational software in the 1990s, and adopted by the OMG in 1997. That's the Object Management Group. The motivation, well, UML was part of a move from procedural programming languages to object orientation. Object orientation is an abstraction that describes a runtime approach that separates function from data, that is, attributes and methods. As mentioned, the Object Management Group currently administers UML. It's an international, not-for-profit organisation, and its rationale is to specify system architecture, design and development planning with the Unified Modelling Language. And the OMG manages a number of standards, one of which is the MOF, or the Meta Object Facility. The MOF defines the concept of a class on which UML is based. So, what is UML? Designed to provide an independent description for architecture and programming, that is, independent of programming language or platform. A meta-model is used to construct UML itself. This meta-model comprises a set of modelling concepts, attributes and relationships, and rules for putting them together. UML starts with the concept of an empty package. The core of UML provides for concepts such as class, package, data type, and operation, and when combined with primitive types such as integer, boolean, and string, represents the fundamental core of UML. From this core, language units are constructed using profiles. UML is not a methodology nor a process, it is in fact a language. And it has developed as a group of language units that provide useful system modelling constructs such as class, activity, and sequence. Fundamental language units have been extended to provide extra functionality. This is the concept of package merge. It's similar to the concept of inheritance, its additive functionality. The current UML spec is version 2.4.1. Through the development of profiles, UML is customized to add contextual meaning to the UML core. We'll see what that means in a moment. UML modeling technology uses the concept of package merge to provide useful constructs such as UML elements, diagrams, connectors, and constraints. UML2, which leading technology comprises, consists of an infrastructure, and that is the UML core, the merging and importing of packages, and the ability to profile or add constructs from basic UML. The superstructure are the defined structural and behavioural elements and the additional constructs. An example of a structural element is a class, a package, a component, and an example of behavioural elements are sequences, use cases. Additional constructs are the connectors that provide the relationships between UML elements. In addition, there's an object constraint language which enables specification of constraints and rules, and of course diagramming, which enables the UML basic elements to be displayed visually. That's a look under the covers of UML technology. It's not quite so complex, and it's useful to understand how UML technology actually works. The structural constructs, for example, classes, components, nodes, artifacts, are used in structural diagrams. For example, class diagrams, component diagrams, and deployment diagrams. Behavioural elements are dynamic constructs, and of course they're used in behavioural diagrams. For example, activity diagrams, sequence diagrams, use case diagrams. In addition, there are supplementary constructs to make your job of modelling easier, and that is the concept of an information flow from one element to another, templates, languages, language-specific data types, and profiling, which enables certain elements to be linked with certain diagrams. UML has been in existence for at least 20 years. The question has to be asked, what is the relevance of UML to the new era of cloud computing, software as a service, platform as a service, infrastructure as a service, which is developed out of the need to optimize the use of software, hardware, hosting, and network technology. To look at both public and private cloud platforms, there are some key concepts for automating deployment as a set of services. First concept's planning, that is, tracking business processes from concept to deployment. Yes, UML handles this very well. Versioning, tracking packages through team development. Yes, best practice UML technology has a team environment and provides for versioning. Automation, database and code engineering in a variety of common formats and platforms. So, what about testing and deployment? It's not difficult to specify test cases and to schedule and implement code. Performance monitoring and auditing. Best practice technology promotes deployment planning with simulation and audit models. So in fact, the use of enterprise UML models provides a head start for cloud computing.